Hello, can you hear me? Hello, do you hear me? You,
Yeah.
please.
Yes.
Yeah, okay. I'm sorry I'm late. My wife is feeling sick. Right now, I think I need a little while to figure out what's wrong with her. So I think I'm gonna do is, I'm gonna come back in about 15 minutes. So if you can just kind of hang around or just check back in 15 minutes. But right now I have to see, she's not feeling well. I may have to cancel class, but first I have to figure out exactly what's going on. Okay,
Problem.
so I'm gonna go ahead and I'm just
Okay.
gonna turn off the camera, and I'll come back in about in 15 minutes and let you know if you can just do something while you can read the review problems that are up on the website in the meantime. But I'm gonna take a break and come back in about 15 minutes. Okay, so thanks. Bye. Yeah,
Oh,
I'm not gonna, and I'll let you know if I have to cancel class or not. Thanks.
Okay. I hope she feels better.
Oh, thanks.
yeah. Hope she feels good.
Hello, can you hear me? I'm back.
Yep.
Yes, we can hear you.
Okay, all right. So she's not fit. My wife's not feeling well. She has a fever. We called the doctor. We're kind of trying to figure out what to do next. So we have time to finish the class. Everything's also strange these days. So she has a fever, but no other symptoms that would indicate a virus infection. But she does have a fever, so we just have to play it by ear. Okay, so go ahead, and there's one thing I wanted to talk about today. We haven't. Okay, let me turn on screen sharing. Let me bring up browser. We haven't talked about, oh, I should mute my camera. Don't need it. There. We haven't talked about return methods. Return from methods. So, well, actually, first, real important, that the syllabus shows the second midterm exam a week from today. Okay, so so on the syllabus, we've got to the point where there's the second midterm exam. So it's a week from, that is a week from today. Okay, so we're going to do it the same way we did the first one. Here is a list of well, first, here's a list of what sections in the book. The exam's going to overlap with the last one. So like chapter 4 was on the last exam, that's methods. Well, we're still talking about methods. So there's going to be some overlap. We'll have a little bit harder problems about methods this time. So it's about methods, if statements, and for loops. Methods, if statements, chapter 5, and for loops. And then these are the same chapters from the other book. So methods, if statements, and for loops. And then here's an outline of the words that we've used, the things that you need to know, okay? And then there's a bunch of problems, okay? And solving the problems is the real way to study. Much better than going, you would read these things as you need to solve the problems. Let the problems tell you what to read. If you can't solve a problem, you can kind of go back and maybe reread something. Like if you can't solve a problem, you can always ask me like, what should I read if I need to understand that problem? I can tell you like what section you might want to read, but solve the problems, okay? So there's a bunch of problems about for loops, if statements, and methods, okay? So if you have questions about the review problems, send me questions. Like last time, I won't send you a solution sheet. So I won't send out a solution sheet, but I will answer any questions anybody has about them. The idea is that you should solve them because that's the best way to be ready. Okay, and then the exam will be like last time. We'll have class, and then after class, the exam will be available, and it'll be due by midnight. Okay, and there's a reading assignment. We're going to start talking about the next topic, which is arrays. But right now, you're preparing for the exam is your real priority. So I mean, this is the reading assignment. If you have time, you can look at it. But your first priority should be studying what the exam is going to be about. Okay, so we'll start talking about these sometime next week. But so I went ahead and put the reading assignment up there so you know what the next topic is. If you have time, you can look at them. I put a couple more coding bat problems because I think they're just real nice problems. They're solving these problems is a very good way to keep up with the ideas. So there's one logic problem and one string problem. Okay, all right. So what I want to do today is it's actually in this list of stuff about methods, we haven't talked about the return, the method return. Okay, return type and return statement. So let's look at examples that do that. Okay, let's emphasize that here today. Okay, so I've got some examples here. Okay, start Dr. Java. We'll actually look at these on the Java visualizer, but let me just open them in Dr. Java first. Okay. We want to talk about this idea that a method can give you back an answer. And the most direct way to think about that is the way you have formulas in like a math class. So for example, in a math class, I can just do some notes down here. Okay. In a math class, somebody could say f of x is, say, in a calculus class, you might have like f of x is 2x plus 3, okay? Or it could be 2x squared plus 3x plus 5. Those are formulas, okay? Now, this to us is the equivalent of a method definition. I'm telling you what a formula is. Like here, this formula essentially is x squared plus x. And the function is f. It takes in an integer number. It returns that answer. And see here, it says, this is saying that the function is going to return an integer answer. And then here's where it returns the integer answer. That's a long verbose way of writing this in a math class. This says, if you give me an x, a number, I'll plug it into this formula and give you back an answer. So for example, if you give me f of 3, the answer will be, I'll write it this way. You'll get out of the function, well, let's see, it'll give you 3 squared is 9. 2 times 9 is 18. 18 plus another 9 is 27. Plus 5, see if I did that right, I should get 32. Okay. On your hand, you could plug in f of 0. That one's an easy one. If you plug in f of 0, you get out 0 squared is 0, 2 times 0 is 0, 3 times 0 is 0, you just get out 5. Okay, so you're used to this idea that you plug a number in and you get a number out. These to us are method calls. That's this. See, that's a method call. So now notice how much more compact math notation is. There's the method definition, there's the method call. Java's kind of much more messy about this. You have to write this kind of elaborate stuff to get the method definition, but Java was designed not for math formulas. It was designed for much more elaborate things than math formulas. So math formulas end up looking kind of messy in Java, but they get across the idea. Okay, I'm defining a function, a method. We use the word method in Java. They're called functions in algebra and calculus class. So and in C++, people tend to call them functions also. So this is a function definition. But to us, that's function and method are just synonyms. Like Java people call it a method definition, but C++ people would call this a function definition. Okay, so I'm defining something named f. Here's where the name goes here. It takes in a variable x. Here's the variable x, but I have to tell you what type it is. So here I have to say it's an int. Sometimes my function will take in strings. Sometimes they'll take in ints. Sometimes they'll take in doubles. Like this one would actually, if it was really a math class, would be a double. You're using decimal numbers in math classes. So if I was really mimicking the math version of this, I would make this one double, but I made it int. Okay. Then this says the definition of the function is what comes afterwards. Well, the opening brace is where you start the definition of the function. Okay. And now the reason we have a return statement is because if I wanted to, I could break this up into steps. Like here, I'm going to take x times x and add it to x. Well, if I wanted to, I could say int y equals x times x, and then return y plus x. See, I'm allowed, in Java, I'm allowed to break it up into steps. Now, you would never do that down here. You just say what the formula is. One of the reasons why Java's way of doing it's more verbose is because you could really have lots of steps before you return the answer. So now the answer is y plus x, but y is just x times x. So I'm still doing that formula. I'm still doing x squared plus x. So you can have a bunch of statements, and then you say, now here's the answer, return the answer. And that goes between the braces, and that we call that the method body. We call this the method body. Okay. All right. So it's very similar to what you do in math. Now here, I'm going to create a variable 1, a w. I'm going to call the method and get back the answer. So f of 3 is 32. And then I'm going to take 32 and add it to 1, get 33, and store that in w. Okay. Then I'm going to do some other more calculations. F of 3 plus f of 4. So that means that I'll have to call the method and do that calculation once. Keep that answer. Go over here, call the method, do the calculation again, get the answer. Then do the addition, which puts the two answers together and store it in W. Okay, so this line of code is got lots of sub-steps to it. Call the method, that's one sub-step. Call the method, that's another sub-step. Do the addition, that's a third sub-step, and then put the answer in W. So there's actually 4 steps going on there. Now here is something you see in calculus a lot when you get to things like the chain rule. This is what we call composition. What do I do with the answer? I take 5, I plug it into F, and I get an answer. What do I do with the answer?
Plug it in F again.
Yeah, see, that's called composing. When the output of one function becomes the input to another function. Okay, now here I only have one function, but it could be 2 different functions. That's called composition. So there's actually 2 steps here. Step 1 is call F with the input 5, and then step 2 is call F again with the input whatever F of 5 was. It would be 5 times 5 is 25. Let's see. So F of 5 would be, we would get out an answer of, let's see, 5 times 25, 2 times 25 is 50, 3 times 5 is 50, that's 65, 70. So I think I get 70. So then you would call F with the input 70. And I'm not going to try to compute what F of 7, see, then you would compute F of 70. Okay. All right. Now let's actually take this and put it in the Java visualizer and watch it. Now if I run this, it's not going to do anything because I don't output anything from this, but actually I can compile it and I can run it, and I won't see anything because I didn't print anything out. Because if I run this in the Java visualizer, I don't need to print things. I can see what the answers are in W. So let's just put this in the Java visualizer. The nice thing about the Java visualizer is I don't really even need to print things. Okay, so okay, so now if I visualize this, okay, I'm about to call F of 3, so I'm going to jump down to line 12, and now notice that I did the parameter passing. Okay, so in our list of vocabulary words, let's see, I'm sorry, let's see. Oh, yeah. See, what we just did was a method call. And the flow of control was we drop down into the method. We drop from the flow controls that we went from line 5 of main to line 12 of the function. So we called the function on line 5 and we jumped down to the body of the method. Okay, and then and as we pass the argument values, the argument value is this thing here. That's the argument. That's the value that's going to be passed to the parameter. So the argument 3, the argument value got passed to the variable parameter x. Okay, so the argument value got passed to the argument variable. Okay, so that's B, C, and D here. You have argument values in the method call. You have parameter variables in the method definition. And when you call a function, you pass the argument values to the parameter variables. Okay, and that just happens in the visualizer. The Java does that for you. It's going to pass that value into that variable. So now we're in the function with x equals 3. So x is 3. now I created a local variable. See, that was one of our other ideas. That was one of our other ideas. We have where is it? Local variable. In the method body, the method can have local variables. So you can have local variables to help you do your calculations, okay? And the scope of that variable is just in that method, okay? So this variable y, it gets created here and it dies when this method dies. And same with x. This x goes away. This, remember, both these variables will go away when this method is done with, okay? So that was what we mean by the scope of a variable. So we have local variables and the scope of the variables. So we're seeing that so far we're using all these words over here. Okay, now I'm here at 13. Now is the interesting part. What that's going to do is going to do this last calculation, and then it's going to return to the line 5 with the answer. Now watch how the visualizer shows us that. See, I'm about to return 12. Okay, 12 is what the f of 3 was. Is that what we agreed on? F of 3 was, let's see. How did let's see, I'm using a different formula over here. Oh, I'm sorry, I didn't even think, I wrote a different formula here than what was up here. And I was doing the calculations down here with the wrong formula. I completely slipped my mind that I was using a different formula down here than what was up here. Yeah, we should use the same formula, x squared plus x, okay? So f of 3 is, 3 times 3 is 9, plus 3 is 12, f of 0 is 0, f of 5 is 5 times 5 is 25, plus 5 is 30. Okay, so I should use the same formula down here as what we're using up there. Okay, so now we've got, see, the visualizer shows us what the return value is. That's what's going to get plugged into that slot there. So now 12 replaces f of 3. So the return value essentially kind of replaces the method call. So one way to think about it is that the method call is being replaced by its return value. Then 12 plus 1 will put a 13 in W. So now I'm going to do the return. Now I don't see really, okay, well, what happens, I've returned, notice I have returned to this line here, and I've returned to this part of it. And now it's about to do the plus 1, and now it's about to store the result in W. Okay, so you saw I actually had to do a couple clicks. So see, here I'm at line 13, then I'm at step 6. So step 6 is the return. I've now returned. Now Java actually needs to do another step. The other step is to take the 12, which you don't see in here, but there's a 12 there. It's going to get added to 1, and 13 is going to be put in W there, and there's W holding the 13. Okay, now I'm on line 6. Well, I've now got to do that call. Now, Java actually has a choice. It could do this call first, or it could do this call first. And it actually, you have, usually Java does them from left. Well, the order of operations for a plus is to do things from left to right. So the order of operations is to do whatever's on the left, work from left to right with pluses. So if there was a f of 3 plus f of 4 plus f of 5, I would work from left to right. So it's going to do the f of 3 first. So watch, I go forward, and I'm down here with x is 3 again. Okay, so I did the f of 3 function call. Now I'm about to return. I'm going to return to line 6 again. See, I'm about to return with a 12, and that's going to go in this slot here. Okay, right now there's a 12 in that slot, but it doesn't show you it. But now we have to compute this guy. So now we're about to go back down here. This is the flow of control that we talked about in the section on methods. I'm following the flow of control. Now the control goes to this thing, but now that control goes down to over here. See, now I'm down here again. I did that, but see, x is 4. So I'm in the middle of doing this one now. Okay, so now f of 4 will give me 4 squared is 16 plus 4 is going to give me 20. See, there's the return value. That return value is going to go in there. So there's something waiting for me in here. And now I'm about to put the 20 there. The visualizer won't show you that. Okay, now we're back to line 6. There's a result sitting here. There's a result sitting here. And now I can do the addition. And W is going to get updated to 32. Okay, now let's look at another one. This was composition. When I go to I'm at this line here. First, I'm going to do this. Yeah, I have to do what's inside first before I can do this one. I have to know what to plug into it. So I'm going to do this one first, so I know what to plug into the outer one. So you work from the inside out. Okay. So, and I can tell I did the inside because there's 5. So the 5 value was copied into that parameter. Okay. So now I'm down here with 5. So f of 5 is going to give me back 30. See, there's the return value. See, the visualizer is real nice about showing you. There's the result that's going to get computed, that's being returned. It computed y, which is 25. It added 25 to 5 and got 30. And now it's about to return 30. 30 will go in that slot there. So forward. Now I'm over here. 30 sitting right there. Unfortunately, the visualizer doesn't show you that, but the 30 sitting right there. Now I have to do that guy. So now I'm going to jump back into the method. This is the composition, a method of a method. Okay. See, now I'm back here with x is 30. The 30 was the result of that thing there. Okay. Okay. And then I get I'm computing the result. The return value is going to be 930. And there, W now gets the return value. Okay. Now let's do all this again. I got a slightly different version of this. Let me show you. Here's a trick to try to get the Java Visualizer to show us what steps are going on. Let me put this in let me open the visualizer again. Okay, so I'm going to create another visualizer window. Okay, now this is the same code, but I took that line and broke it up into 3 lines. And I took this line and broke it up into 4 lines, because I want to show you this is a little trick. We've used it once or twice before. By putting all these pieces on different lines, we actually see the Java Visualizer which part of the line it's jumping to. So we actually kind of can see that the Java Visualizer is sometimes doing this and sometimes doing this. Whereas over here, it would just jump to this line. If it was in there, it would be in line 6. If it was there, it would be in line 6. If it was doing the assignment, it'd be in line 6. You didn't see it in different places. Same here. If it's doing the inner function, it's on line 6. If it's doing the outer function, it's on line 6. So here, notice I even broke the inner function on its own line, and the outer function's kind of wrapped around it. Now, Java doesn't care where you put your, Java can let you format things any way you want. So Java doesn't care if I write things kind of funny like this. And it'll let us see like what order these things are being done in. So let's go ahead and visualize it this one. And okay, now we're at line 5. When we step forward in this one, when we step forward, we really are going to be doing, see, now remember how we have to click once and you don't know what it did. I just did a step, but what was it doing? It was going to this. Then I do another step and it goes down here. Here, it becomes a little bit more obvious. I start here. What's the step after 5? It's to go to 8. See? So I went from 5 to 8 because I have to do 8 first. Okay, now I jump into the method. I'm about to return 12. I return 12 to here, so there's the 12. Now, the next step should be do the addition, and then the next step should be assign it to W. But the visualizer does not show those steps. Okay, so if I go forward, it's just gonna see it did everything. It did steps 2 and 3 in one click. It didn't really show it going to step 2 and do that line, and then go to this line and do the assignment. So there really is these 3 steps: compute the F, compute the plus, assign the value to W. But the visualizer only showed us one of those steps. So the visualizer started here on line 5, and we see that it did step 1, call the method. We're finished with step 1, and then it just does step 2 and 3 in one click. Okay, so it showed us a little bit. Now here, again, what's going to happen here? There's really 4 steps. First, we should do this thing. Then when it's done, we should do that thing. Then when it's done, we should add them. And when we're done adding, we should put the result in W. The visualizer will show us some of these steps. So for example, it shows us, now we're over here, the visualizer would just show us always on line 6. You know, you can't see if you're over here on line 6 or over here on line 6. But in this one, okay, first I'm going to go to step 1. Go down here, do step 1. I'm returning 12. So 12 is done. Now what's the next thing? The next thing is call f of 4. So the Java visualizer shows us, yes, it goes down to the 4, f of 4. So now it calls that method. Okay, see, I've got the 4 in the parameter. I'm about to return 20. So now I've done step 1, I've done step 2. Now the visualizer would be nice if it showed you line 12 is the next step and then line 10 is the next step, but it does not break those into separate steps. It just, in one click now, it's going to go to line 15. Okay, so see, it just went to line 15. So it did the step 3 and 4 without showing them to me. So I saw the step 1 and the step 2, but I didn't see the step 3 and the step 4. Now, same thing kind of here. The first thing I have to do is f of 5. That's step 1. Okay, so so notice how it went straight from line 15 to line 17, because the first thing you need to do is the inner function. So it went to line 17. Go down here, do the calculation. I'm going to return 30. Okay, now this is interesting. See, it came back to step 2. See? So see, after it computed this, the next thing to do is step 2. Now step 2 is going to take 30, it's going to take this result as its input. So we're in step 2 with the input of, remember, see, the return value is 30. Oh, notice how the return value kind of disappears. In the middle of doing step 1 and step 2, that return value, it's really sitting right there, but you don't see it, so in a sense. Okay, so the return value was 30. Okay, that's now going to be the input to that F. So go down here. Now, see, there's 30 as the input to F. That 30 was the result of step 1. Okay, now I do a calculation. I'm going to return 930. Okay, I'm done. Now the 930 is about to be put in 15. So it should show me going to step 15, to line 15 next, because I'm about to put the answer 930 into W. But it just kind of, it just does that without showing you, highlighting that step. So the last thing it did was put the 930 in W. So it did the inner calculation, then it did the outer calculation, then it put the result in W. Okay, so you can kind of see the steps a little bit better this way. Okay, over here, programmers just get used to those steps. They see this and they know that first you calculate that, then that answer is going to be passed to that function in another function call. Then the result from that then gets put into W. So there's 3 steps there. Notice that those 3 steps are different than these 3 steps. Here you call F once, and then the answer is held, and then you call F again, the answer is held, and then the 2 answers are added. Here, you call F once, and the answer is held, but then that answer is fed right back into F. So you call F 2 times, but in a different way. answer from this one is the input to this one. Here, this one produces one output, this one produces a second output, and then the two outputs are added. But you get two you get two method calls, and here you get two method calls. Okay, all right. Let's do another example that's real similar to this. I've got another example with two variables instead of one variable. Real similar idea, but we can do a little bit more complicated things. So here is now if I was doing math, this would look like the following in a calculus class. The function f takes in an x and a y, and it returns the formula 2 times the x plus 3 times the y plus 1. So there's the math formula. Okay, that's what it would, that's how you would write it in a math class. And then you can ask, well, what's f of 2 comma 1? Well, f of 2 comma 1, we can do the calculation. You plug 2 into x, that gives you 4. Plug 1 into y, gives you 3. 4 plus 3 is 7. Add 1, you'll get 8 out of that. Okay, and you can also do actually I called it g, so I used a different letter. I'm using the letter G in my code, so I should use the letter G down here. And then I can take G of 1, 2. That's not the same thing as 2, 1. 1, 2 is not the same thing as 2, 1 because the order matters. This puts 1 into x and 2 into y. Okay, so the order matters there. So now the answer here would be, okay, so I put 1 into x, I get 2. I put 2 into y, I get 2 times 3 is 6. 6 plus 2 is 8, plus another one, I get 9. Okay. Now here, if you think about this w here, there's an order of operations here. First, you've got to compute. See, first you have to do this addition. Actually, you do that addition first. 5's already there, but you need the right-hand side of it. So before you want to do that addition first, but before you can do it, you need to know what's on the right-hand side. So in fact, you actually do this first. And the reason is because you're really doing the addition first, but you don't have the right-hand side for it. So you do this first. Then when you get that answer, you could finish that addition and then go do the second addition from left to right. So you do this first, then that addition, then that addition. Okay, over here, we want to do that addition. But we need to know what's on its left. So we do that first. Then we want to know what's on its right. So we do that first and then add the two results. Here's a funny composition. G takes in two numbers. The first number is 5. The second number to that G is the answer to that call to G. So it's a form of, notice it's a slightly different kind of function composition than what we did here. We just said f of 5. Here, it's just a little bit trickier. It's G of 5 comma G of 6, 7. So you have to compute this number. You have to compute this first. Then with that answer and the 5, you can compute that G there. And if I wanted to, I could do another example. I could do the following. G of 3 comma 4, G of 5 comma 6. Now there's 3 calls to G. It's another example of method composition. It's still a method composition, a more complicated one. Okay. You want to compute that G. You need to know what its first number is. To find its first number, you have to compute that G. Then to find the second number for that G, you have to compute that G. Then you have 2 numbers, and then you can compute that G. So you have 3 calls to G. Okay. That'd be a little bit like, it's not quite the same thing as if you did something like this. There's 3, I'm sorry, another one. Okay, there's 3 calls to F. Okay, but notice that there's 3 layers to this one: outer, inner, innermost. So there's function in there's a function inside of a function inside of a function. There's 3 layers here. This one, even though it's got 3 function calls, it's not 3 layers, it's only 2 layers. There's a function inside of a function and a second function inside of that function. So they're really the same. They're a little bit different. In a minute, we'll go back and do them, and you'll see that the big difference is there's 3 calls here, but not all at once. You make this call, and you make this call. They're separate, and then you make this call here. Okay? In a sense, over here, well, you know, notice if you one way to think about it is if you started this call, you'd have to suspend it to find out this number here. Then if you started this thing here, you'd have to suspend it to do this one here. So then you'd have 2 suspended ones, and you'd be working on this one. Now that's not the way Java does it, but there's some languages that do it that way. They start with this one and then suspend it to say, oh, I have to figure out what's inside. Java actually works from the inside out. So Java just jumps straight to this, does that. When it gets that answer, it does that. When it gets that answer, it does that. But here you would have to suspend that F and then suspend that F and then start that F. Here, you would start that G and suspend it. Okay, say, oh, I started it, but I can't do anything until I have to do this. But you'd finish that one. Then you'd finish that one. And then you could go back and this one. So you wouldn't have 2 suspended functions. You'd only have 1 suspended function because there's only 2 layers to this one. This one's a more subtle thing of actually 3 layers, a function of a function of a function. Okay, all right. So now let's watch this one in the Java visualizer. If we watch it in the Java visualizer, it looks pretty much the same as the one we just did. Okay. We want to see the steps. Now, actually, if I do it like this, I don't see the steps. So I wrote it in. Yeah, we can break it. Well, let's okay. Like right now, I know that it has to do this first because it can't do the plus. So it will go to down here with the 2 and the 1. So it had to do what's inside here first. Okay. Now we're about to return an 8. The 8 gets put back in here. Okay, we don't see it, but there's an 8 right there. Okay, that's an 8. Now the next step is it's just going to do all at once, that addition, and the assignment. So then it just goes to the next line. So it puts 16 in W. Okay, now here we know that we're going to really jump to this one first. Okay, so X is 1, Y is 2. See, X is 1, Y is 2. So we jumped down here to do this one. Then we return 9. We just returned 9. It's there. The 9 is there. So now we're about to go to this one. And Java for us remembers that there's a 9 there. So now we're going to go with X is 3 and Y is 4. Okay, now we're in G with X is 3, Y is 4. Okay, we're about to return 19 to there. Okay, we're back here. Now there's a 19 there. I forget what was over here now. I forget what's over here, but now we have a number there and a number there. And now in one step, it's going to do the addition and store it in W. So there's the answer in W, 28. Okay, now here, the question here is like, are we sure that Java goes to this one first? You know, could it somehow go to that one first and then somehow do this one as part of it? And the answer is no. It's going to go to that one first because it needs that answer before it can start that one. So it's going to go straight to this one. And we'll see that we're going to get x6 and y7. Okay, so there's the x6, y7. So we're doing this one. So we're down here doing this part. Notice we jumped inside and we work from the inside out. Okay, so like I've mentioned many times, you don't read programming languages from left to right. You know, they're more like mathematics. You have to read them in the order of operations. In this case, the parentheses tell us to do what's inside parentheses first. So you work from the inside out. So the most inner parentheses is the 6, 7, the G of 6, 7. So we're going to return 34. Okay, now 34 there's a 34 right there. Okay, now X is 5, Y is 34. We're going to call G with X5, Y34. Okay, there it is, X5, Y34. So the 34 was plugged in there, and then we computed the G, we called G with those two values. And then now we're about to return 113. The 113 will go there, and it'll get put into the W. And it'll just do that in one more click. Okay, now the 113 is there, and it's about to be put into W. Okay, so it just got put into W, and we went to the next line. Okay, and now we got a similar kind of thing. We have to do this, before we can do this G, we have to work from the inside out. We have to do this one. Then we have to do that one, and then we can do the answer. Okay, so notice that X is Y, X is 3, Y is 4. We did this one on the left first. So we did that one first. We're about to return 19. 19 is going to go there. We don't see it there, but the 19 is there. Now we're going to go do this. So X is 5 and Y is 6. So now we're down here with X is 5, Y is 6. Okay, so we're doing this part. We're about to get an answer. The answer is going to be 29. So now 29 is sitting there. We don't see it, but a 29 is sitting there. We've got an answer sitting there and an answer sitting there. So now we can do the G with those two answers. Okay, there's G with the two answers, the 19 that was here and the 29 that was here. Now G is working on those two answers. Where were those answers when we didn't see them? What actually happens is that the Java language does what you would do. It keeps scratch, like you would do this with a piece of scrap paper, and you'd keep these numbers on a piece of scrap paper. Java creates variables that are hidden from us and remembers these answers in hidden variables. So like that answer was being remembered in a hidden variable, and that answer was being remembered in a hidden variable. And then those two hidden variables were passed to G. So Java does these things, and the visualizer doesn't show those hidden variables, and there's no way to see them. But later on, if you will learn how to see them eventually. But there's actually extra variables being created to hold these intermediate answers. And so that's where they really are. They're actually on the stack. There's essentially hidden variables up here that you don't see that are being used. Well, actually, they're in main. The hidden variables would be part of main. There's hidden variables in main that remember that answer and that answer so that those answers can be plugged into X and Y in the function call. Okay, and then there's the return value is going to be 126. So that's the return value of that G. So that whole thing is 126 now. So that 126 is about to be put into W. One more click, and then 126 is in W. Okay. We've run out of time. Okay. So let's see. There's one more thing we're going to be yeah, so we'll do some more examples like this next week. We'll do more examples with returns, because a return, for some reason, returns cause a lot of confusion. Every year when I teach this, I'm surprised that it's easy to get confused by the notion of return. Return seems to be the hardest part of understanding methods. So we'll do more examples, and what we're going to see is, I want to show you. we want to talk about the difference between printing something and returning something. You almost never print answers. You always return answers. One of the important differences, and this is where I say people get confused, the difference between that and that. That's not a return. That's a return. A lot of people mix these up. The method printed the answer versus the method returned the answer. Okay? If you delete this, the method's not returning an answer, and now it's a void method. That's one of the things we have to talk about. That's a void method. It gives me an answer, kind of. The answer shows up on the output screen, but now this stuff here is all broken. There is no output from G to feed into another G. So this doesn't work at all. And that's one of the important things we want to talk about. The difference between returning an answer and printing an answer. Okay, so we've run over time, so we should quit. If you've got questions, please send me emails and ask for, and ask questions. And let's see. So I'll go ahead and stop sharing. Let's see. Oh, have a nice weekend, and we'll see you again on Monday. And have a happy Halloween. Hope you can enjoy Halloween somehow. Okay. All right. Let's see. Oh, I'm lost there. I want to stop sharing. Right. Okay. All right. So see you on next Monday. Bye.